Now we're going to progress, okay? Now, I would still probably typically do this at the inception, even if I'm going to move into a lift with this component, because it gives me an initial capture on this to help reduce the likelihood of this shifting while we have guys in much more hazardous positions around this load putting in struts, okay? If we're going to lift, we're going to talk about strut lifts, we're going to talk about airbag lifts, but you can see very quickly with this application, short of trying to lift off of the firewall under here, the airbag applications are really, really limited, okay? So most of the time, this is going to be one of two types of lifts. Either a high directional anchor lift, where we rig up a bipod up above this load, capture it, and either use the bipod as a gantry or lift directly through a fixed bipod using a hauling system, a grip hoist, a chain hoist, any type of cable system. Or we're going to lift from the ground using struts. Today we're going to use hydrofusions. When we put in these struts, we want to have a strong awareness of the angle relationship between the struts and the load. So just like some of the side vehicle stabilization components we've done, we want to make sure that we're in that roughly 45 to 60 degree range, okay? It's important that you think about load that's being applied to the struts when you're doing true lifts. So as a general rule of thumb, from just an engineering perspective, at 45 degrees, whatever load is being assumed vertically, I am transferring that load at 1.5 times that load laterally. That plays a big role with commercial vehicles or heavier vehicles when we start thinking about our anchoring materials, our ratchet straps, our chains, our connectors that go from base plate to base plate or base plate to independent anchor. So to kind of put meat and potatoes to that, if this was theoretically a 1,000 pound load that we lifted, what I would be transferring with a 45 degree relationship on that strut would be 1,500 pounds on those straps, okay? So we want to consider that. We also want to understand that the more vertical we make our struts, the less that lateral tension is, but also we start to lose lateral stability. So you're always trying to find that married balance between vertical lifting capacity, reduction on lateral tensioning elements, but also maintaining lateral stability. So here's how this all basically plays out. We want to throw struts to this vehicle as primary stabilizers. The primary function is vertical and lateral stabilization. Then we're going to put secondary struts in here that are lifting struts. We're going to put hydrofusion bases, under traveling struts. They're going to be the lifting components. Your lifting segments should be thrown in at about 55 to 60 degrees, okay? Your stabilizing struts should be thrown in at about 45 degrees. That's going to give us a good balanced marriage between stabilization, lifting capacity, and reduction on tensioning elements. Now, the other important thing we need to discuss is how do we anchor all this stuff? How do we take these bases and secure them so they don't shift, travel, move, and they're engineered well, right? I really believe in load triangles. So as we analyze this load, we want to understand that there is a pivot point and there is a lift point. We want to make sure that we secure the pivot point, we draw it in towards the bases to make a tight package, and we prevent it from kicking out. If we don't secure that pivot point, then when we go to lift, the whole thing can shift, all the struts can go with it, and things go downhill really, really quickly. So when we talk about a load triangle, what we're talking about doing is creating two bases with two struts that travel up to the load with a ratchet strap going from base plate to base plate. We're then going to take two additional ratchet straps. So we're going to go from each of those independent base plates up to the nose of the vehicle. When we draw those in from the pivot point on the undercarriage, that's what secures the travel or the pivot point of the vehicle to the bases, gives us a nice tight triangle package for lifting and stabilization. So we're going to get all that laid out. Remember those basic fundamentals. Look at your load, identify the pivot point and the lifting point. Do a quick load calculation if it's necessary, depending on what kind of struts you're using, to ensure that your struts measure up with what you're putting on them, okay? They got to have an appropriate design load for what you're doing to them. Stabilizing struts, lifting struts. Always be redundant in those applications to make sure that you're balancing things out if you can. If you've got enough resources, it's going to give you a much more secure, much more safe, and much more stable lift. All right, now there's a lot of different variables here. We're not going to be able to hit them all, but I'm going to try and talk about some basic considerations when you go to rig this. For the stabilization pieces, okay, the struts that are going to stabilize laterally, I like to go higher on the load, all right? If I can go high on the load and basket the entire load with a chain, it gives me a real secure carriage that encapsulates everything. When you go low on loads with stabilization, the load has a tendency to dance around on you a lot, as opposed to going high and letting it hang from high stabilizers. So what we've elected to do is run our lengthier struts. We're going to put 610s in here with multi-base heads and our 12-inch vehicle base plates. We're going to run these up high on this quarter panel, and we're going to run a chain as a basket rig right through this wheel well to each side. We're going to try and keep these struts just inside of 45 degrees. We're going to get them tensioned up with that ratchet strap so we secure this. Once it's secured, then we're going to connect our ratchet straps from here up to the undercarriage nose of the vehicle, giving us that good load triangle. Now we've got a good stable imprint for these. We can get in closer and more directly in line with the load. We're going to think about where our balance point is on this, okay? It's not going to be the B post because all of the weight is up in the engine compartment. So your balance points on vehicles is typically between the A post and the B post, meaning balance point just like a ladder. If we were to put a fulcrum or a midpoint underneath it, would it teeter-totter like a seesaw? You've got to make sure that your lifting element with the hydrofusions is behind that balance point so that we don't totally destabilize the load. So for our hydrofusions and our lifting struts, we're going to come back just in close proximity to these Bs. We're going to come directly under here at a much more vertical angle, capturing the frame rails under here, and we're going to lift from the lower side. There are a lot of options with this. If you thought you had enough stability, you could potentially put your hydrofusions right in here, do a direct lift off of the rear, run some additional stabilizing struts here to the side. You could also blow out your side glass, capture the high roof line. Remember that your roof line, if the load truly gets unsecured from the lifting points and loads these side struts, or if you need to alter your lifting struts, meaning rebuild and pull them out, anything along those lines, if you place the entire load on these stabilizing struts, and what they're attached to is the roof line, you've got to understand that you're putting the entire load of the vehicle on a roof line, which isn't a real secure structural element. That's why for these chasers, I really like basketing and rigging high. You're always going to be attached to a good secure element, and if you need to load these fully and change your lifters, you're engineered well. Okay, now here's one of the things about chain, right? When you start with chain in a basket rig like this, you're going to have a lot of slack in it. So you're going to pull it through manually as tight as you can get it, right? Then we're going to tension up these ratchet struts, but we don't want to alter our angle a whole lot, okay? We want to stay in that wide squat for good stabilization. So tension up your ratchet straps so they're lightly tensioned, and you have that at about the angle you want. Once you're at that position, we're going to remove the slack from this chain by extending out the struts. That's why controllable extendable struts are so important. If you've got a pinning system where you got to manually extend something, pull it out of a hole and repin it, applications like this are not going to be smooth. You're going to have to rely totally on your ratchet strap, which is almost always going to tweak your angle and put you real vertical. So I'll go to the other side, Scott will work this side. We're going to get our locking nuts spun out until we get the slack out of that chain. You'll notice that we start with our multi-bases a little bit low, so that we have some distance to travel on this quarter panel to extend up and secure this chain. At this point, we've extended up. We're about maxed out on our quarter panel. The vast majority of the slack is out of our chain. You see we got a pretty tight rig there. We're going to goose it just a little bit on our ratchet strap now. You see we got pretty good angles and they're pretty well married on both sides. Scott, go ahead and tension just a little bit. Good, stop. Now, you want to make sure that you got an officer or crew chief that's out here at the front. He's going to eyeball the angle on both of those struts. It's really important that they're similar. If one strut is thrown real vertical and one's thrown real lateral, if they ever load, meaning we lift and then we place the load on them and do something with our lifting struts, the load's going to have a tendency to want to shift. You really want to marry these up if you're ever going to have them as standalone captures. So if you look, you can see that it's pretty close. We're a little bit vertical, not quite as wide as we could have been, but we've got a nice package and we've got good lateral stability, good vertical stability. Now we're going to make our load triangle. So we're going to go from the base plate here up to the nose of the vehicle. If you don't feel like you have this well secured now, then don't try and go to a frame rail or an inset position that's under the vehicle. If you feel like you have this really well secured, then you can tackle that frame rail. If not, stay on the outside, go to a fender, make an anchor point through the fender body, or go right to the wheel. Just remember, if you're going to wheels, they move. They move, they pivot, they can spin, they make them a somewhat unreliable anchor point, so just be cognizant of that if that's what you select. We've got this well secured and captured, so we're going to reach right inside, right underneath the front nose of the vehicle and go right to the frame rails up front.
Got that. There. Good spot.
Yep, that's right where I'm going, buddy. Real quick on me. When you set these and tension these, you'll notice that we've got a little bit of a setback angle coming up to the high side of the load. That's really important, especially when you look at this as a pendulum, how it's going to potentially lift. If you come up with these and run them basically perpendicular to ground, there's a possibility that when this load starts to come up, these are going to want to walk towards the back of the vehicle. The other challenge is if you do a load triangle like this and you're perfectly squared up to ground, when you go to tension these front straps, there's really nothing opposing these from being pulled in this way. Whereas if you can squat them out just a little bit, then as they get drawn in this way and drawn forward, it's going to kind of bring them into position but not displace your base plate. So just a little bit of a setback angle.